Everyone. So the next physical application of Calculus 2 that we want to look at is work. We have an intuitive idea of what work is, but in physics, work is something that's calculated using force and displacement. There's one situation we can handle without needing calculus. That's the situation when the force is constant. In this special case, the work done will just be equal to the force times the displacement. It's really important that you recognize this is only true if we're dealing with a constant force. As an example of how to calculate work done by a constant force, suppose we have a constant force, 20 pounds, that moves a chair from x equals 1.9 feet to x equals 2.1 feet. Because this is a constant force, the work is just equal to the force times the displacement. We take our force of 20 pounds and multiply it by our displacement of 0.2 feet, which is 2.1 minus 1.9. Notice when we multiply pounds times feet, we'll get units of pound feet, which is the US system units for work done. So 20 times 0.2 or 20 pounds times 0.2 feet will give 0.4 pound feet. So there are some common units you're going to be seeing for work, and those start with the units for force. In the metric system, the unit for force is a newton, which is defined as a meter times a kilogram per second. And in displacement, you'll be typically seeing that in terms of meters. In the US system, force is measured in something called a pound force, usually abbreviated LBF, or sometimes just called a pound. And displacement is typically measured in feet. It's very rare that the force being applied is constant. Usually, the amount of force being applied depends on how you've already moved the object or where you are in some physical space. So if we have a variable force, big F of x, moving an object in a positive direction along the x-axis from point A to point B, the work done by the object. To make this discussion less abstract, let's talk about a specific type of physical object. Here's an example of a variable force problem. Suppose we have a force of 3x squared that moves an object from x equals 1 to x equals 2. And let's say the force here is in newtons. We're moving from x equals 1 meters to x equals 2 meters. This is a variable force because it depends on x. So in this instance, I would approach this as the definite integral from 1 to 2, 3x squared dx. We know that the antiderivative of 3x squared will be 1/3 x cubed. So I plug that in and subtract. Get 1/3 2 cubed minus 1/3 1 cubed, 8/3 minus 1/3, or 7/3. The units here will be newtons times meters, also known as joules. So 7/3 Newton meters or 7/3 joules would be equal to the work done. I didn't actually say that in the original question, and I definitely should have.